Hi folks, my name is Rajiv. I am a principal PM on the Key Vault team. I'm here to talk to you about what's new and some of our future roadmap that we have upcoming for Key Vault. I'm going to talk to you about three things that we've done for Key Vault today. One is private link for Key Vault, show you our story around secrets rotation and our roadmap that we have planned for that. And finally, I will talk about Azure policy and its use with Key Vault as well. At the end, I'm going to save about 2 minutes just to cover a couple of other new but minor items that we have released for Key Vault that I wanted to quickly make you aware of. So before I get started on Azure Private Link, let me take a few moments to explain a couple of common terms. One is Azure Private Link. First, what is it? It is a service that we are now offering that is allowing you to connect private link to your specific Azure PaaS service. So in our case, that means really Key Vault, and how we connect that over a private endpoint and a private IP in your virtual network. Finally, you should know what a public endpoint is, and that's basically a way of how anybody connects on-prem or through any public network specific to your specific Azure PaaS service, in this case, Key Vault as well, without the use of VPN or ExpressRoute. And finally, of course, there's the term private endpoint, which is simply just the network interface that connects you privately and securely to the service powered by Azure Private Link. So don't get too much caught up in these specific terms, because at the end of the day, it's really all about how you configure these things to work seamlessly end-to-end over a private IP network to your specific Azure PaaS service. So there are a few terms that you should be familiar with. I am not going to go into what each of these things are. They are well documented out on our Azure networking site. So if you need to look at any of these things, these would be the key ones that I suggest you look at. So the thing I wanted to specifically talk about first is what have we offered before we release private endpoint. So we have service endpoint, and that is effectively allows your VNet to connect to your Azure PaaS service via the Microsoft backbone. Now, in and of itself, this is not a bad thing, right? There is a level of protection that is afforded to you if you configure your PaaS service in this particular way, right? Issues here is that your Azure PaaS service is still a public IP address, and you have to open up your network service group, open up to your service tags. You also have to remember is that there isn't really any native data protection in this particular case, right? You still have to use a firewall in order to make sure that you are protecting your data. Now, the other thing to note about service endpoint is that when you open up an Azure PaaS service, it is not specifically opening up that specific instance. It's basically opening up the entire portion of that PaaS service to that specific VNet. So those are things that some people will like, and that's some things that we have heard very clearly that's simply not enough. So that is why we continued down the path with developing this further, and that's where private link was effectively born. And so what that is that allows you to still travel via a Microsoft backbone and create an entirely private network. Your PaaS resources map to your specific IP address, and the NSGs are restricted specifically to that VNet space itself. And thus far, that also means you have an inbuilt data exfiltration protection. So as you can see, you have a complete end-to-end private network in this particular case. So what are the benefits of private link? Of course, one thing is you reduce your risk of data exfiltration. So you'll be able to block outbound connections to the internet from your virtual network. If an attacker were to compromise your VM, get access to your Key Vault, they cannot transmit your data outside the virtual network whatsoever, right? You have improved granularity of access control. So as I mentioned earlier, when you had service endpoint, you are basically enabling access across that entire PaaS-based service. In this particular case with private endpoint, you are now able to specifically connect only to a specific instance. So in this case, you will have a specific instance of how you're connecting to an individual endpoint for Key Vault. And then, of course, then you can still connect privately to services in other regions. So your virtual network and private endpoint can be in region A. You can connect to region B. The connection is completely private across all of the security world boundaries. So as I mentioned earlier, let me just show you a small brief example of what that really means. So in this case, we have configured a specific private endpoint. You see the 10.0.0.1 address. That is specifically mapped over a private link to that specific key vault on the right side. All the other unmapped accounts simply cannot be accessed. So there can be multiple other key vaults that you can configure this to be, and you will not have access to those specific PaaS-based resources. So let me just walk you through a little bit about what we've done with Key Vault, right? You have basically 3 layers of protection that Azure has to offer in this particular case. You have, of course, your public internet, and that's where traffic traverses the internet. You're securing your specific Azure PaaS service based on ACLs. Corporate firewalls are open to Azure, and basically that is how the traffic flows. Not great. That's not usually what people want. You have another option where you can use MS peering, and you are specifically connecting to Key Vault in this particular case using ExpressRoute or ExpressRoute. Traffic stays within the Microsoft and partner network, and you have to still open up your corporate firewall to the Azure public IPs. And of course, now we'll give you the best of all of those worlds, which is now you have private link, which is traffic is fully private, traversing the Microsoft network only. There's no exposure of public IPs. Corporate firewall is only open to the private network itself. Okay, and with that, I'm going to turn it over to Shane, and he'll give you a brief demo on private link.
Thank you, Rajiv. Hello, everyone. Thank you for joining. My name is Shane Bala, and I'm a program manager with the Azure Key Vault team. Today, I'm going to be showing you a quick demo of private link for Azure Key Vault. In this demo, I have set up 2 virtual machines, each connected to a separate virtual network, and I'm going to show you how both VMs can access a secret that I store in Key Vault over the public internet. Then I'm going to set up a private endpoint connection between virtual machine 1 and the Key Vault, and then I'm going to turn on the Azure Key Vault firewall. You'll be able to see that VM1 will still be able to access the secret stored in Key Vault because it has a private path to the Key Vault, and virtual machine 2 will lose its access because the connection from the public internet will be denied. So I will be doing the majority of this demo using Azure CLI. I will be going through the commands pretty quickly, so if you need a copy of these commands, they are available in the How-To Guides section of the Key Vault documentation, which will be linked at the end of the presentation. So the first thing that I'm going to do is I'm going to log into the Azure CLI environment. And then I'm going to set my subscription. And I'm going to set Microsoft Key Vault as a provider. So now I'm actually going to create my Key Vault, and I'll take a second to pause here. So when you set up a private link connection, the private endpoint and the virtual network must be in the same region. In this case, that's West US. But the Key Vault target can be in any location. In this case, I'm setting it to East US. And the name of the vault I'm creating is Build 2020 Test Vault. So now that my Key Vault has been created, I'm going to give both of the virtual machines access policy permissions to retrieve secrets from the Key Vault. So I'm going to be using the MSI IDs of each VM, and I'm assigning both of the VMs get and list permissions. So that's permissions for VM1, and this is permissions for VM2. And I'm going to go ahead and set a secret. In this case, I'm going to be setting a secret with the name secure password. And of course, the value of that password is going to be password123. And now at this point, the Key Vault's firewall is still off because I haven't configured it. And now let's go to both VMs and make sure that they can both access the secret. So here I have both virtual machines. I have virtual machine 1 on the left and virtual machine 2 on the right. And now both VMs are still connected over the public internet. So they both should be able to retrieve the secret from Key Vault. Let's go ahead and test it. So here's virtual machine 1. And as you can see, it's able to retrieve password123. And now let's go to virtual machine 2. And as you can see, virtual machine 2 is also able to retrieve the password123. So now that I've showed you that both virtual machines can access the secret, let's go ahead and set up the private link connection. So I've already gone ahead and created the virtual networks, but when you use private link, you need to run this command to disable private endpoint network policies. This is a prerequisite for using a private endpoint within a virtual network. All right. And I've already gone ahead and created the private zone DNS. Here is the command that you need in order to actually create the private endpoint. All right, now that the private endpoint has been created, I need to switch back over to the Azure portal. And now what we need to do is we need to go to our private link demo resource group. And we actually need to go into that first virtual network. And the private endpoint is going to take up a private IP address in that virtual network. We need that private IP address, and we need to create a record for it in the private DNS. So I'll go ahead and I'll copy this IP address. And then I'll go into the private DNS zone. And now I'm going to go ahead and create a new record set. And I'm going to enter the name of the vault here. So build 2020 test vault. I'm going to create an A record, and I'm going to enter the IP address that I copied over. All right, now that that's been created successfully, I'm going to go over to the Azure Key Vault firewall, and I'm going to make sure that I turn the firewall on. So now I've navigated back to my build 2020 test vault, and now under settings, I'm going to go to the networking tab and switch allow access from all networks to private endpoint and selected networks. And now I'm going to go ahead and hit save. And now, since I haven't provided any additional firewall rules, this is going to turn on the Key Vault firewall and prevent all access from the public internet. All right, now that we have set up the Key Vault firewall and we have set up the private link connection between our VM1 and the Key Vault, let's go ahead and see which virtual machines still have access to the Key Vault. So in virtual machine 1, you can see that if I try to retrieve a secret, I'm still able to get password 123. From virtual machine 2, I am denied by the Key Vault firewall. So in this demo, we were able to show how to set up a private link connection to Key Vault and how to retrieve a secret from Key Vault over a private link connection. I hope you enjoyed this demo, and I'm going to hand it back over to Rajiv. Thank you.
Okay, thank you, Shane. Let me talk to you about the next section that we are doing with Key Vault, which is all about secrets rotation. So we believe secrets rotation is a core functionality of any secrets manager. In other words, why do we think this is important is because any type of secret can eventually be broken. And it's certainly going to depend on the amount of time and the amount of compute power that you have, but eventually almost all secrets can be broken, which is why we want all people to be rotating all of their secret types. Now within Microsoft, we have a bunch of guidelines on how often we want certain types of secrets to be rotated. Passwords, for example, will be 70 days, certificates will be 2 years. But we expect those rotation periods to come down over time as compute power continues to increase. The other thing you have to ask yourself is, what happens in a breach? Would you be able to rotate 100,000 secrets quickly? After some exposure has occurred, how quickly can you rotate your specific secrets? Now today, Key Vault only natively supports certificates and native rotation of certificates and MSACs. And we have a plan here that's going to actually allow you to rotate any and all of your secret types. So we have put together within Key Vault the beginnings of a secrets rotation framework. And effectively, it is an event-driven architecture. And we monitor the secret for basically 3 types of changes: new secret versions, an expired secret, or secrets near expiry. And across all of those 3 specific events, we are sending those specific notifications through our notification system through Event Grid, which I will get to in a moment. right? And the reason we chose Event Grid is because it has a guaranteed event delivery with built-in retries, and it's super, super scalable. At the end of the day, Event Grid is all about a message passing service. And if you've ever built anything across any sort of message passing service, you know how fast and how many messages can flow across that entire service very, very quickly. So within that framework as well, we use Azure Functions basically to do the event processing, which means you send that event across any of those three specific event types that I had mentioned earlier. Those things will flow through Event Grid, and then it is our recommendation to use Azure Functions. You can also use Logic Apps as well, depending on what you're doing. And you will be able to rotate any of your specific secrets using that entire framework. So today we have already provided, and Jack will walk you through this in a few minutes, already a common secrets rotation function specific to SQL. And you can go out there today and you can find that out on GitHub and download that to use to help with secrets rotation. And we have a couple of more out of the box ones that we're going to be offering for Redis and storage coming in June as well. But the key with Azure Functions, it allows you to support your own custom specific scenarios. As it turns out, secrets rotation is a super, super difficult area in mind that is hard for many people to solve. And we know we won't be able to do that across every single RP, for example. And you will have your own custom scenarios where you will need to rotate those specific secrets itself. So we're giving you functions, you can extend them yourself to actually do the secrets rotation. And of course, with functions as well, you have 7 programming languages that are supported. So anything that you want to do and extend, you'll be able to do that using functions itself. Now, I mentioned earlier, you can also use logic apps, and that can be helpful if you are doing things that need to run on a timer, for example, or a scheduled type of connection where you need to have something updated. And it has over 300 other connectors available. So we wanted to create this entire environment such that it will scale to whatever needs you have across any language and, of course, any other connector as you go forward. So in a nutshell, this is basically how it works. Within Key Vault, you get the near expiry event that is sent off to Event Grid. You then write a function which will then go out and through the framework. First thing is to create the new secret version, and then it will update the various secret types across Azure Storage, SQL, Cosmos DB, and there's more that's on the way, or your own custom, whatever your own custom RP might be in this particular case. And similarly with logic apps, and it basically works the same way. Once you have set up the environment, it is very fast and very quick, basically handle secrets rotations in this type of framework. Now, a lot of people are using the expiry notifications to even do things like simply like alerts. They want to know how to rotate their certificates, and that's perfectly fine. If you've got these custom ways of why you need to go do so, we do recommend using this way of doing so. So let me give you a little bit about what our roadmap is with secrets rotation. So right now we have this in preview. We will show you an example here in a moment, and Jack's going to take over for me, give you an example of how to rotate a single user, single credential scenario, and that's going to use Event Grid and notifications. And then we'll actually create your own function and subscribe through Event Grid. Hopefully by the end of the year, we are targeting the dual credential scenario, so you'll have to keep those things in sync between a primary and a secondary key scenario. And then we'll also be adding native rotation through the Azure portal with built-in functions, hopefully also by the end of the year. And so with that, I am going to turn it over to Jack, and he will walk you through how to do secrets rotation.
Hello everyone, my name is Jack Lichwa. I'm a Senior Program Manager on Azure Key Vault. Today I want to show you how to rotate SQL password stored in Key Vault using Azure Function. Let me start with the diagram. You have Key Vault with SQL password stored as secret. When that secret is about to expire, which is set to 30 days before expiration, Key Vault publishes event to Event Grid. Event Grid, based on event subscription, calls Azure Function to perform rotation. Azure Function performs rotation by generating new password, storing that password in Key Vault as new version of the secret, and updating SQL database with that password. I will walk you through how it can be set up. For this demo, I will use Visual Studio Code and Azure Cloud Shell. Initially, I created empty Key Vault with SQL database with initial password. Let me list those components. Both components are created in East West region and under the same resource group. Now I will test database connection to make sure that we can access database with current credentials. For that, I will use SQL extension. Connected successfully. Now I can start creating function app. Function app requires storage account for managing triggers and logging. I will create storage account first. Create it successfully. Now I can create function app to host functions. Function app will use consumption plan in East US. And since our function is written in .NET, we'll use .NET as runtime environment. Function completed. Now let me make sure that all components were created. Okay, now it's all. We have a consumption plan in East US region. We have function, and we have insights for monitoring. Now I'm ready to deploy function. For that, I downloaded code from GitHub, and I will use Azure Function extension to deploy it. Select my subscription and our function. Deployment started. It will take a few minutes to complete, so in the meantime, I would like to walk you through function code. It starts with the event handler. Event handler receives event, reads secret information like secret name, secret version, and key vault name, and then calls rotation method to perform rotation. Let's go to the rotation method. In a rotation method, it first calls key vault to retrieve secret. Then it reads SQL information from secret tag and log it. After that, we validate connection to SQL database to make sure that function can access SQL database before we start rotation. And then we generate new password, create new secret version. Let me show you the actual method. We passed user ID and data source from tags, and we added as tags to new secret version. We also add a secret expiration days, which is currently set for 31 days. And after that, we update database with that password. Let's go back to our Cloud Shell. script. Deployment still continues, but now we will be able to use the Cloud Shell. After function is created, we also will need access for function to Key Vault. For that, I will use manage identity, and I will use that identity to create access policy in Key Vault. So let me start with assigning identity to a function app. And now we can copy principal ID and paste it in object ID parameter. Also, we can see that function deployment already completed in background. And now I can create policy in Key Vault. Our policy limits permission to secret operation like get, list, and set. And that's all what function will need. Now we need to create event subscription. Event subscription will require event grid to call Azure function. And for that, we'll need to retrieve host key. We'll use the REST API for it. Host key created. Let me copy and add it to our function endpoint. And now we can create event grid subscription. We'd like to mention that our subscription just subscribed to the secret new expiry event and using subject as SQL password, which will be our secret name. Now we are ready to add SQL password to Key Vault. For that, we will use tomorrow date as expiration. So new expiry event triggers immediately. Let me run it in terminal. As we can see, new secret is created with password build demo 123, and that's what we have in our database. And let's wait maybe a few seconds and check secret value again. And now it has new generated value. Let me test that new password with our database to make sure that SQL Server was also updated. Let's remove that connection. Okay, and now let's connect create new connection profile, and I forgot to copy entire string, so let me do that. Let me first update that password in connection string. And copy that to the console. And database connected with new password. Our rotation is completed. The function we just created can be easily reused to rotate all secret passwords in your database just by adding new event subscription. Entire code can be found at GitHub link below, and there is also a tutorial which describes all those steps. Thank you. I give it back to Rajiv.
Okay, thank you, Jack. So the last thing I'm going to talk to you about is Azure Policy. So what is Azure Policy? We have adapted policy to basically use with Key Vault to monitor and govern all of your resources, your secrets, your certificates, and even other types of vault policies, for example, like soft delete, and make sure that you can manage them in your environment across at scale. How does that help you? It eliminates the need for any sort of manual auditing, performs continuous checks on what's in your environment, and helps keep you compliant. So you can easily find what are the types of secrets that are across my organization. How do I know that I have always everybody using a minimal key size? And what are the types of certificates that I have? Do I want to make sure that soft delete is enabled for all my vaults so I don't have an accidental deletion of a secret that I cannot recover? These are the types of things that policy can help you with, and that's what we have designed this thing to work at scale to help you manage your vaults. So policy for Key Vault allows you to govern your secrets centrally. It allows you to manage those secrets at scale and across your organization. You can control and create your own policies within the organizations for things like soft delete, for logging, and of course some of the other things I have mentioned, which is always creating a minimum key size of the types of keys you want to create in your environment, or certificate strength. We've also given you the ability to build your own types of policies, such that if there is something that we haven't thought of that you can change at the control plane level of Key Vault, you will have the ability to edit those JSON files and create your own types of policies, if you will. So there's a few things to remember across for policy. You have the policy definition file, which is simply a file in JSON format that allows you to create a set of business rules that correspond to what you are trying to audit or enforce within your environment. And then, of course, you have the ability to assign that policy, and that can be across any specific management group, a subscription, a resource group, or individual resources within the policy assignment itself. And of course, then you can actually enforce all the various policies. So that means you can have an audit mode or deny mode. Audit mode, you simply see the compliance status of all those resources within the scope of that policy. In deny mode, all resources that do not comply with policy definitions will be blocked from being created. So you can probably start to see how powerful this simple tool become in helping you to manage all of your secrets across all the large parts of your specific organization. Right? We have heard from many different customers. They have things like Vault Sprawl, and they just have no idea where their secrets are, the types of secrets that they have, no visibility into the compliance of what those secrets are all about. Then it's super, super hard for everybody to really manage those secrets. You can audit them periodically, but they're using a manual process. And there isn't any current first-party solution that allows you to exist or audit all of those secrets in the vaults for the compliance, right? And of course, now you can start to enforce your organization standards at scale. So if you want to make sure that everybody is using only 2048-bit certificates, now you can do so. And you will be able to stop the creation of those should you choose to do so. So we have created 3 different areas for policy at this point. You have audit mode, which allows you to just broadly apply that policy across your environment to determine the types of secrets that you have without breaking anything. It will just give you a complete inventory of the types of secrets that you have, their strengths, other information about them that you would want to know. And it's audited continuously in an automated manner. So you always know exactly which secrets are compliant and which ones are not. And of course, as I mentioned earlier, you can assign the scopes. So you can limit the assignment of the scope to simply a management group all the way down to the individual resource. So you can divvy up different policies, maybe different parts of your finance organization's needs higher scale key strengths to protect financial data as an example, versus something else that only requires something a little bit less. And then of course you have the ability to enforce those policies as well. So you can block the creation of any non-compliant secret objects should you choose to do so. Okay, and so with that, I'm going to turn it over to Shane, and he's going to give you a demo of how to use policy.
Thank you, Rajiv. Hello, everyone. My name is Shane Bala, and I'm a program manager with the Azure Key Vault team. Today I'm going to be showing you a quick demo about Azure policy for Key Vault. I'm going to go through an overview of the test environment that I have here. I will walk you through selecting a definition. In this case, we're going to audit certificates that don't meet minimum key size requirements. In this case, that's going to be RSA 3072-bit. I'm going to show you how to assign policy to a scope and to exclude certain resources from that scope. I'll show you how to view compliance results of a policy and turn on enforcement of a policy, and we'll get to see a deny in action. So a quick overview about the environment that I have set up here. You can see I have 3 key vaults set up in this resource group. The first is a compliant vault. This vault is going to contain all certificates that are compliant, in this case RSA 3072-bit or higher. This is the non-compliant vault. It'll contain certificates that don't meet that requirement. And this is the test vault exclude. So this is supposed to represent some dev test environment that you have that you don't want policy to apply to, and you don't want any deny actions to take place here. So the first thing I'm going to do to select the definition is I'm going to go over to policy. In the search bar, under authoring, I'll see definitions. And I'm going to select the category as Key Vault. So as you can see from this list here, we have a lot of preview policies that you're able to assign. All of these policies relate to certificates. We will be adding support for keys and secrets soon. So the policy that I want here is manage minimum key sizes for RSA certificates. I'm going to go ahead and click on this definition. And you can see the JSON definition here with certain parameterized allowed values. So I'm going to go over and hit assign. And from the scope, I'm going to select my subscription and my resource group. Now, in the second tab, I see exclusions here. So I'm going to go ahead and choose the key vault that I don't want to be within the scope of this policy. That's my test vault exclude. And I'll go ahead and hit save. And I want to take a minute to talk about this policy enforcement switch here. So when you turn on a policy, you have the ability to turn it on in enforcement mode. So if you deploy it through an ARM template and you don't necessarily want denies to start taking into effect immediately, if you want to turn on your policies one by one, you can roll out your policy in disabled mode and then turn on one by one as you test. In addition to this, if you roll it out and there's some issue, you can quickly turn off the policy enforcement without having to go through another deployment or without having to remove the policy entirely. So for now, I'm going to keep this as disabled because I'm going to show you the deny after. So let's go into the parameters, and the minimum key size that I want to enforce is 3072-bit. And in this case, I'm going to switch it over to deny. So when you set an effect to deny, it implicitly does an audit as well. But keep in mind, it won't actually start blocking the creation of certificates until I turn on that switch in the other screen. So now I'm going to go ahead and review and create the policy, and I'm going to go ahead and select create. So at this point, I do want to mention that from the point you create a policy assignment, it can take up to 2 hours for all of the resources in your scope to be fully scanned and for you to start viewing compliance results. So for the purposes of this demo, I've actually already gone ahead and created this identical assignment. And I will show you how you can view assignments to make sure that your policy did in fact get assigned correctly, and I'll show you how to view compliance results of your policy. So we're going to go back to the policy tab here, and I'm going to go to assignments. And as you can see, the policy to manage minimum key sizes for RSA certificates has been successfully assigned. And now I'm going to go to compliance results, and now I can see the results of that policy. So to view the compliance results in more detail, I'm going to go ahead and click on the policy. And as you can see, I can see my non-compliant resources here, and it's listed as non-compliant vault. I can also go ahead and select this dropdown to see my compliant resources. And of course, my compliant vault is showing up. And because I did not include the test vault exclude in the scope of this policy, it's not going to be visible here. So I'm going to switch back to non-compliant resources. And I can actually click on the vault and I can see the individual certificates that are in this vault that are causing this to be non-compliant. So now I'm going to go ahead and turn on policy enforcement and show you how that works. I'm going to go back to my policy dashboard. I'm going to go into my assignments. I'm going to click on the minimum key size for RSA certificates policy, and I'm going to make sure that my policy enforcement is set to enabled. And then I'm going to go ahead and hit review and save. So again, I also want to point out that when you do start the enforcement action on a policy, it can take anywhere between 15 and 30 minutes to start applying to your resources. So again, for the purposes of this demo, I've already gone ahead and created this policy assignment. And let's go ahead and see a deny in action. So now in my compliant vault, I'm going to try and create a certificate that is RSA 2048-bit and does not meet the compliance requirements. And as you can see, if I generate a certificate with the name test deny cn equals test.com, I'm going to set it to RSA 2048-bit, and the policy will deny the creation of the certificate. So as you can see, I see an error. The operation create certificate was denied because of the manage minimum key size for RSA certificates policy. Now, if I go ahead and just change that to 3072-bit, and I hit create, the operation should succeed. And as you can see, now that operation has completed successfully because the certificate now meets the requirements. And if you go back and I go to my test vault exclude, I should be able to create a certificate that is RSA 2048-bit in this vault, because this vault does not come under the scope of the policy. So I'll create another cert. And I'll set this to, again, 2048-bit. And this operation will succeed because this vault is not within the scope of the policy. So I hope you enjoyed watching this demo, and I'll hand it back over to you, Rajiv. Thanks.
Okay, thank you, Shane. Two quick things I want to wrap up with as we end this presentation. We have enabled soft delete to be on by default and purge protection to be configured from 7 to 90 days. Both of these are available in the portal and the CLI today. PowerShell should be available later this month. Please turn this on for your vaults to make sure you can protect your data and don't do an accidental deletion. The last thing I wanted to bring to your attention is that we have done a lot of work to change the Key Vault docs, put a lot of new samples and a lot of other integrations, so you can clearly see how to use Key Vault across your different secret types, whether that be certificates, keys, or secrets. There is more coming here, but please do take a look and make sure you give us any feedback if you have any other specific questions there. Other than that, thank you so much.